Hello, welcome to you all in my channel Mechanical Engineering Concept. Today I am going to continue my previous topic, which is the mechanical vibration, in which we already discussed about what is the basic definition of vibration, what are the components which are in the vibrating system, what are the different types of element like spring, what are the types of spring and their application with respect to the major usage and with respect to their basic influences. And now today I am going to continue my previous topic, spring, with a combination of a spring. What are the different combination we can discuss in the spring? So basically we can discuss spring with a two part. One is the series combination, and the second one will be the parallel combination. So how to understand series combination? First let me draw a one diagram. Suppose one of the spring is connected to the another spring with one end fixed and other is free, in which first spring has a stiffness K1 and second spring has a stiffness K2. Then it combination will be come out as a resultant value of a equivalent spring. It can be represented as a KE. Combination of these two spring can be represented as a KE. This is known as series spring, series combination spring. How does it KE value come out? So imagine another spring KE which has a equivalent value. It is known as a equivalent stiffness. Okay, when the force F is applied to that spring, the spring K will undergo the deflection del, which is equal to the series combination value del, because these two spring will be represented as this kind. How the equation will be come out? Let us discuss. As I can say that if I applied a force in this series combination here, F, then this spring will deflect del 1 amount and this spring will deflect del 2 amount. Spring 1 will deflect del 1 amount and spring 2 will be deflected with del 2 amount, and the total deflection will be come out as del. So the final equation will be come out as a del is equal to del 1 plus del 2. The total deflection del will be come out as a del 1 plus del 2. Okay, so as we know that load is equal to stiffness into displacement. Okay, so displacement can be written as force upon stiffness. So this equation can be written as load upon stiffness. Stiffness will be equivalent stiffness for a total displacement here, and del 1 will be come out as a F divided by K1 plus F divided by K2. This F will be cancel out, then the final equation will be come out as 1 by Ke is equal to 1 by K1 plus 1 by K2, and our Ke will be come out as 1 by Ke can be simplified as a, take it as LCM K1 K2 K1 plus K2, then our equation will be come out as Ke is equal to K1 into K2 divided by K1 plus K2. this is the final equation for spring which is in series combination. So the series combination spring can be represented with respect to number of springs. Suppose 1, 2, 3, n number of springs are given to us in a series combination. This n number of spring can be represented with a single spring which is known as a equivalent spring. This value can be represented as a k1 into k2 and so on and so forth till kn divided by k1 plus, suppose n number of springs are given to us in a series combination, k3 and dash 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 plus kn. This will be the equation for equivalent spring, equation for a series combination. Now let us discuss about a parallel spring. So to understand parallel spring, first we need to draw a diagram. Consider two springs are in parallel connection because the parallel combination are given to us, and a load is applied at the free end. One end is fixed, another is free. So at free end we applied a load F. So with the application of load F, the spring will deflect total amount del. Okay, total amount of del. Okay, but the total deflection will be same for both the spring because it will move from here to here. Okay, so how to calculate the equivalent spring? Suppose initial spring has k1 stiffness, final spring has a k2 stiffness, then this can be represented as this equivalent spring. So what is the value of ke equivalent spring? This we need to calculate because k1 has a del 1 stiffness, k2 has a del 2 stiffness, and here del 1 is equal to del 2 is equal to del because the force at both the spring at a same plane. So the both the spring will deflect same amount. So del 1 is equal to del 2 is equal to del. So how the both the spring has the same deflection? If the each spring has a different forces, because both the spring has a different stiffness. So the for the same amount of same amount of deflection, we need a different amount of forces, because if F is equal to, we know that K into del. If the del is constant, then F is directly proportional to K. K will change, then F will change also. So for each spring, forces will be different. So for K1 stiffness spring, force will be F1 consider, and for K2 stiffness of spring, we consider force of F2. Then the total resultant force can be represented as F is equal to F1 plus F2, and as we know that F is equal to K into del, so put the value here, K into del, Ke into del, for total resultant force, K equivalent stiffness into deflection is equal to K1 into del 1 plus K2 into del 2. As we know that del 1 and del 2 are equal to del, then this will be cancelled out, and the Ke equivalent value will become out as K1 plus K2 is equal to equivalent value. Okay, so this is the value of equivalent stiffness in a parallel combination. This is the two basic major consideration which we need to discuss. In place of spring, we can consider element, bar element, beam element. Okay, because each element, each machine element, each component has some amount of stiffness with respect to its modulus, because modulus is directly proportional to stiffness. So for the calculation, for understanding simplification, we basically considering stiffness value, because more the stiffer the component, lesser it will deflect. More less the stiffness of the component, it will more deflect, because stiffness is inversely proportional to del. If we take a constant F, then K is inversely proportional to del, or del is inversely proportional to K. So more the stiffness, less the deflection, less the stiffness, more the deflection. So due to that, we're basically considering the series a parallel combination with respect to spring. Okay, so because in a vibration analysis, we're basically considering each component as a spring element to for calculation simplification, for design simplification, to understand the basic concept of vibration. So I hope you understand the basic concept related to the combination of a spring. If you have any doubt related to this topic, then please tell below this video in comment box, and don't forget to subscribe my channel, and please do like and share this video to your friends. They also can get benefited with that. Thank you. Have a good day.